So we're here at the example table, and in this video we're going to be talking about iterated integrals over rectangles. So let's start with this example. The first thing to remember is that the order of the dy and dx are very important. This is what tells you which variable the 4 and the 5 correspond to and which variable the 0 and the 1 correspond to. So we know that since the dy comes before the dx, it's associated with the inner integral. The dx comes after, so it's associated with the outer. You work from the inside out. Now, to see that this is a rectangle, we see that y is ranging from 4 to 5, x is ranging from 0 to 1, so we're integrating the function x cosine of xy, or finding, you can think of this as finding the volume underneath the surface determined by this function, over the rectangle illustrated here. So to do this, we first determine this integral, this inner integral with respect to y. When we do that, we get the integral from 0 to 1 of, well, now we need to find the antiderivative of this thing with respect to y. If x is a constant, maybe x is 5. Think of x as 5. We've seen examples like that in single variable calculus. We know that this is going to involve a sine of xy, and actually it's exactly sine of xy, because when we take the derivative of this, we get cosine of xy times the derivative of what's inside with respect to y. The derivative of what's inside with respect to y is just x. So an antiderivative of x cosine xy is simply sine of xy. Now we evaluate this from y equals 4 to y equals 5. And this expression is the new integrand of this x integral. So let's simplify this. We have the integral from 0 to 1 sine of 5x minus sine of 4x dx, and finding antiderivatives for each of these, we get negative cosine 5x over 5 plus cosine 4x over 4. And we evaluate this between 0 and 1. So we plug in 1 and we get negative cosine 5 over 5 plus cosine of 4 over 4, and then minus this expression when we plug in 0. When we plug in 0 for x, this becomes cosine of 0, this becomes cosine of 0, both of which are 1. So we get plus 1/5 minus 1/4. Let's do one more example. So let's again integrate from 0 to 1 and from, not 5 to 4, 4 to 5. This time not x times cosine of xy, but just x times cosine of y, dy dx. So this is a little bit different. We don't have x's and y's mixed inside the cosine. So in this example, we can do something a little bit different. This is still equal to the integral from 0 to 1. Well, actually, let's look at this carefully. So inside, the inside integral is the integral from 4 to 5 x cosine y dy. As far as this inner integral is concerned, x is constant, which means we can pull it out front of this integral. So we have the integral from 0 to 1 x times the integral from 4 to 5 of cosine y dy dx. Now let's look at this again. What's inside this pair of parentheses here is a constant. It's just a number. We have x times a number being integrated from 0 to 1. We can factor this number outside of the integral. So this is the same as the integral from 4 to 5 cosine y dy times the integral from 0 to 1 x dx. So in a case like this, where we can express the integrand as a product of functions, one of which is a function of x, the other is a function of y, and they're sufficiently nice functions, and we're integrating just over a nice rectangle, we can actually write this iterated integral as the product of two integrals. So when we anti-differentiate cosine of y, we get sine of y. So this first integral is sine of 5 minus sine of 4. And the second integral, an antiderivative of x, is 1/2 x squared. We evaluate at 1, we get 1/2. We evaluate at 0, we get 0. So we multiply this by 1/2.